So the first concept is gradient. So gradient, also known as slope, is a measure of steepness of a line segment. For example, if I ask you, which of the three line segments here is the steepest? That means, which of the three line segments here has the greatest gradient? So you'll surely think about the line segment A, since it is steeper than B and C. Likewise, the gradient of B is greater than gradient of C, but gradient of B is less than gradient of A. Since B is steeper than C, but less steeper than A. So if I name the gradients of the line segment as MA, MB, and MC, so I can say MA is greater than MB and MB is greater than MC. Now find the gradient of the line segment L1. Now understand that gradient is the ratio of vertical change, that is rise, to the horizontal change, that is run. So to find the gradient of this line segment, I will select 2 points. So the first coordinate I am choosing is 4, 5, 4, 5, and the second coordinate I am choosing is 0, 0. So the vertical change here, or the rise, is 5 units, and the horizontal change here, known as run, is 4 units. So the gradient of this line segment L becomes 5/4. Now there is another way of seeing this. The gradient represented by M is the ratio of vertical change to the horizontal change. So I can write the vertical change as difference in y coordinates and the horizontal change as difference in x coordinates. So the line L1 is passing through 4, 5 and 0, 0. Now the gradient of the line segment L1 becomes y2 minus y1 divided by x2 minus x1. And I can call 4, 5 as x2 and y2 and 0, 0 as x1 and y1. So the gradient becomes 5 minus 0 divided by 4 minus 0. So the gradient becomes 5/4. Now find out the gradient of the line segment L2. So first we will try to find out the gradient using the gradient formula, that is y2 minus y1 divided by x2 minus x1. And then we will try to find out the gradient using the rise and run concept. So I'll choose the coordinates 0, 0 and another nice coordinate, that is -5, 4. So the two coordinates of the line L becomes 0, 0 and -5, 4. Now let's call this x1, y1 and this coordinate as x2, y2. So the gradient becomes 4 minus 0, that is y2 minus y1. 4 minus 0 divided by -5, -0, that is x2 minus x1. So the gradient becomes 4 minus 0 is 4, or -5, -0 is -5. So the gradient becomes -5/4. Now you must have noticed that the gradient of the line L2 is negative, and the gradient of line L1, which we have calculated earlier, was positive. So why is this so? So to understand this, try finding out the gradient of this line using the rise and run concept. So gradient is also given by the rise and the run. Now you can see that unlike the line L1, the rise is downwards. So the rise is -4 and the run is 5. So the gradient becomes -4/5. So in general, lines that slope downward from left to right have negative gradient, and lines that slope upwards from left to right has positive gradient. The gradient of vertical line is undefined or 0, and the gradient of horizontal line is also 0. So horizontal and vertical lines have a gradient of 0. Now understand the gradient of parallel and perpendicular lines. Now remember that two parallel lines will always have the same gradient. So looking at the first example, if these two lines are parallel, they will have the same gradient. For example, they both have the gradient of positive 3. Now, for the second example, they both might have the gradient of 0. And for the third example, if the two lines are parallel, they both have, for example, the gradient of negative 2. So, in general, parallel lines will always have the same gradient. Now, for the perpendicular lines, remember that their gradient are always negative reciprocal of each other. For example, if the gradient of this line is 2 over 3, then the gradient of the line perpendicular to it will have the gradient of negative 3 over 2. Since negative 3 over 2 is the negative reciprocal of 2 over 3. Now, for the fifth example, if the gradient of this vertical line is 0, then the gradient of horizontal line will also be 0. Lastly, if the gradient of this line is 6, that means 6 divided by 1, then the gradient of the line perpendicular to it will have the gradient of negative 1 over 6. Since negative 1 over 6 is the negative reciprocal of 6 over 1. Now let's do a few more examples. So if the gradient of this line is 5, then the gradient of the line perpendicular to it will have a gradient of negative 1 over 5. Since negative 1 over 5 is the negative reciprocal of 5 over 1. If the gradient of this line is 5 over 6, then the gradient of the line perpendicular to it will have a gradient of negative 6 over 5. So what you need to observe is perpendicular lines have gradient that multiply to give negative 1. So M1 is the gradient of a line and M2 is the gradient of the line perpendicular to it. So M1 times M2 is always equal to negative 1. So 2 over 3 times negative 3 over 2. 2 over 3 times negative 3 over 2 is always negative 1. Also, 5 over 6 times negative 6 over 5 is also negative 1. So 5 over 6 times negative 6 over 5 equals negative 1. So in summary, perpendicular lines have gradient that are negative reciprocal of each other, or you can say perpendicular lines have gradient that multiply to give negative 1. Now let's get to know what is y-intercept. So y-intercept represented by C is the y value at which the line intersects the y-axis. So this line intersects the y-axis at y equals 2. So the y-intercept of this line equals positive 2. Now the y-intercept of second line equals 0 since the line passes through the origin. So the value of second y-intercept equals 0. Now the third line has a y-intercept of negative 3 since the line intersects the y-axis at y equals negative 3. So the value of third y-intercept equals negative 3. Now understand the most important concept. This coordinate here is 0, 2. This coordinate here is 0, 0. And this coordinate here is 0, negative 3. So we have 0, 2, 0, 0, and 0, negative 3. So I can say that y-intercept is the y value when x equals 0. For example, if I say that I have a line segment And this line segment passes through 0, 6. So that means the value of y-intercept is 6. I have another line segment that passes through 0, -1. That means the value of y-intercept is -1. Now, what is x-intercept? So, x-intercept is the x value at which the line intersects the x-axis. So, this line here intersects the x-axis at x equals -4. So, the value of x-intercept here is -4. Now, for the second line, x-intercept equals +1. And for the last line, x-intercept equals 4. Now, note that this coordinate right here is -4, 0. And this coordinate right here is 1, 0. And this coordinate right here is 4, 0. Now, you can say x-intercept is the x value when y equals 0. For example, if you have a line segment that passes through 5, 0, that means the x value here is 5. And so is the x-intercept. Also, if I say that I have a line segment that passes through -2, 0, that means the x-intercept of this line is -2. And this coordinate right here is -2, 0. So in summary, y-intercept is the y value at which the line segment intersects the y-axis. Or you can say y-intercept is the y value when x equals 0. Also, x-intercept is the x value where the line intersects the x-axis. Or you can say x-intercept is the x value when y equals 0. Now, any straight line has equation in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So, to find the equation of this line, we need to have its gradient and y-intercept. And we can see that this line has a y-intercept of 0. Now we need to find the gradient. So gradient is change in y over change in x. Or you can say this is equal to rise over run. So if I am choosing the coordinates 0, 0 and 5, 5, then we have the rise of 5 and the run of 5. So the gradient becomes 5 over 5, that is equal to 1. So the equation of this line becomes y equals 1x plus c. Y equals 1x plus c and c equals 0. So the equation simplifies to y equals x. Now find the equation of the line L3. The line L3 is a straight line and it has equation in the form y equals mx plus c, where c is the y-intercept, and from the diagram you can see that it has y-intercept of 1. Now we need to find out the gradient of the line L3. Gradient represented by m is rise over run. So if I'm choosing the coordinates 0, 1 and 3, 4, so the rise is 3 and the run is also 3. So the gradient becomes 3 over 3, that is equal to 1. So the equation becomes y equals mx plus c, where m is 1. So 1x plus y-intercept c, which is also 1. And you can rewrite it as y equals x plus 1. Now find the equation of the line L4. So equation will be in the form y equals mx plus c, where c equals 2. So the equation becomes y equals mx plus 2. Now we need to find out the gradient of the line L4. So for the gradient, I will choose any point on the line. So I am choosing 0, 2 and -3, 3. So here you have a rise of -1 unit and a run of 3 units. So the gradient of this line becomes rise over run. Since the rise is negative, so -1 over 3. Note that the gradient of this line is negative since the line slopes downward from left to right. You could also find the gradient using y2 minus y1 divided by x2 minus x1. So you have the coordinates -3, 3 and 0, 2. So let's call this as x1, y1 and -3, 3 as x2, y2. So y2 minus y1 becomes 3 minus 2. And x2 minus x1 becomes -3, 0. 3 minus 2 is 1 and -3, -0 is -3. So the gradient becomes -1 over 3. So the equation of the line L4 is y equals mx plus c, where m equals -1 over 3. So the equation is y equals -1 over 3x plus the y-intercept, that is 2. So y equals -1 over 3x plus 2. Now we figure out the equations of horizontal line. Since horizontal lines are also a straight line, they will have equation in the form y equals mx plus c. As you have learned, the gradient of a straight line is 0. So this mx term becomes 0. Then the equation of horizontal line is y equals c. That means y equals the y-intercept. So the equation of the line L1 becomes y equals 5. The equation of line L2 becomes y equals 3. The equation of line L3 becomes y equals -3. And for line L4, y equals -6. So horizontal lines always have equation in the form y equals something. And that value is always the y-intercept. Now, note that at any point on the line L1, the y value will remain same. Only the x value will change. The y value here equals 5. That means at any point on the line, y equals 5. On the line L2, at any point, the y value equals 3. At any point on this line, y value equals -3. At any point on the line L4, the y value remains as -6. Only the x value changes. Now, for the equation of vertical lines, understand that the x value on it always remains constant. For example, on the line L1, this coordinate, for example, is -6, 1, -6, 3, -6, 6, -6, -2, -6, -5. So the x value on it always remains as -6. So the equation of this line L1 is x equals -6. The equation of line L2 is x equals -3. Since the x value on it always remains as -3. -3, -3, -3, 1, -3, 6. And the equation of line L3 is x equals 2. And the equation of line L4 is x equals 6. Now for the equation of x-axis, you need to understand that x-axis is a horizontal line. And it will have equation in the form y equals something. So on the x-axis, the y value is always 0. For example, this coordinate is 1, 0, 3, 0, 5, 0, -4, 0, and -7, 0. So the equation of x-axis is y equals 0. And on the y-axis, x coordinate is always 0. For example, this point is 0, 3, 0, 5, 0, -2, 0, -4, and 0, -6. So the equation of y-axis is x equals 0. Now let's apply all the concepts learned. The points A, B, and C are 2, 6, 8, 9, and 5, -6 respectively. Find the gradient of the line AB. So you have a point 2, 6, that is A, and 8, 9, that is B. So to find the gradient of the line AB, we will use y2 minus y1 divided by x2 minus x1. So let's call this x2 and y2, and let's call 2, 6 as x1 and y1. So the gradient will become 9 minus 6, that is y2 minus y1, divided by 8 minus 2, that is x2 minus x1. 9 minus 6 is 3, and 8 minus 2 is 6. So 3 1 time and 3 2 time. So the gradient of line AB equals 1 over 2. Now for the part B, find the equation of the line through C which is parallel to AB. So you have a line which passes through point C, which is 5, -6, and this line is parallel to line AB. That means this line will have exactly the same gradient as line AB. So this line will also have the gradient of 1 over 2. Now let's call this line as L1. So the equation of L1 will be y equals mx plus c, where m is the gradient and c is the y-intercept. Now the gradient of the line L1 will be 1 over 2 since it is parallel to AB. So y equals 1 over 2x plus c. Now I know that the line passes through 5, -6. So for y, I'll substitute -6. And for x, I'll use 5. So -6 equals 1 over 2 times 5 plus c. So -6 equals 5 over 2 plus c. So c equals -6, -5 over 2. So c equals -17 over 2. So the equation of line L1 becomes y equals 1 over 2x, which is the gradient. So that means the line L1 will have y-intercept of -17 over 2, which is same as -8.5. So the equation of line through C, which is parallel to AB, is y equals 1 over 2x, -17 over 2. Now consider you have a line segment L1 and you have another line segment L2. And you need to find out the point of intersection of line L1 and L2. So for that, we need to have equations of line L1 and L2. For example, you have a line segment L1 having equation of y equals 2x minus 7 and a line segment L2 having equation of y equals -3x, y equals -3x plus 13. So here you have line L1 with positive gradient and y-intercept of -7 and line L2 with negative gradient and y-intercept of positive 13. And you need to find out the coordinates of this point of intersection. So if I consider the equation of line L1, which is y equals 2x minus 7. So I can replace this y with -3x plus 13. Since the value of y from line L2 is -3x plus 13. So -3x plus 13 which is same as y, equals 2x minus 7. Now the equation will rearrange to negative 3x, negative 2x equals negative 7, negative 13. So negative 5x equals negative 20 and x equals negative 20 divided by negative 5. Now the negative signs will cancel and 5 1 and 5 4. So x equals 4. So that means the x coordinate of this point of intersection equals 4. Now we need to have the y coordinate. So you can substitute x equals 4 either into the equation of line L1 or the equation of line L2. So I'm choosing to substitute in the equation of line L1. Line L1 is y equals 2x minus 7 and you have x equals 4. Y equals 2 times 4 minus 7. So y equals 8 minus 7. So y equals 1. So the y value of the point of intersection is 1. And the point of intersection is 4, 1. Now remember that I could have substituted x equals 4 into the line L2 and I could have got the same answer. For example, y equals negative 3x plus 13, which is the equation of line L2. And for x, I need to substitute x equals 4. So 3 times 4. So y equals negative 12 plus 13. So y equals 1. You have got the same answer by substituting the x value in the equation of line L1 and equation of line L2. Now, let's have another example. You have a line segment L1 having equation of 2y equals 8x plus 6. And you have another line segment L2 having equation of y equals 2x plus 2. And you need to find out the point of intersection of the two line segments. The line L1 has equation 2y equals 8x plus 6 and line L2 having equation y equals 2x plus 2. So consider any of the two equations and then try to eliminate one variable from that particular equation. So for example, I am taking the equation of line L1, which is 2y equals 8x plus 6. Now from the line L2, I know that this y equals 2x plus 2. So the equation will become 2 and for y, I'll substitute 2x plus 2 equals 8x plus 6. Now 4x plus 4 equals 8x plus 6. Now rearrange the equation. So you'll get 4 minus 6 equals 8x minus 4x. So minus 2 equals 4x and x equals negative 2 over 4. So x equals negative 1 over 2. X equals negative 1 over 2. Now to find the value of y, substitute this value of x in either equation 1 or equation 2. Now to find the y coordinate of the point of intersection, substitute x equals negative 1 over 2 in either line L1 or L2. So I am choosing equation of the line L2. So you have the equation y equals 2x plus 2. Y equals 2x plus 2. Now for x, substitute negative 1 over 2. Y equals 2 times negative 1 over 2 plus 2. So this will become y equals negative 1 plus 2. So y equals 1. So you have the coordinate of the point of intersection as -1 over 2, comma 1. Now understand the concept of midpoint of a line segment. The midpoint of a line segment is a point that lies exactly halfway between 2 points. For example, given the two coordinates 7, 4 and 5, 4, the midpoint is exactly halfway between these two. So to calculate the midpoint, you take average of the x and y value. So let's call the midpoint of the two coordinates as m. And m is given by x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Let's call this x1 and y1 and 5, 4 as x2 and y2. So the midpoint will be -7 plus 5 divided by 2, comma, 4 plus 4 divided by 2. So -7 plus 5 is -2 and -2 divided by 2 is -1. So -1, comma 4 plus 4 equals 8. 8 divided by 2 is 4. Now let's have another example. You have a line segment with n points -3, -2 and 6, 4. So to calculate the midpoint, you will take the average of x and y values. So midpoint m is given by x1 plus x2 divided by 2, which is the average of x values, and y1 plus y2 divided by 2. So first, let's call this x1 and y1 and 6, 4 as x2, y2. So the midpoint m becomes -3 plus 6 divided by 2, comma, -2 plus 4 divided by 2. So midpoint m equals 6 minus 3 divided by 2, that is 3 over 2, comma, 4 minus 2, which is 2, 2 divided by 2 is 1. So the midpoint m of the line segment is 3 over 2, 1, or you can rewrite it as 1.5, 1. So 1.5, 1 is the midpoint m. A and B are the coordinates -5, 5 and 7, y respectively. The line segment has midpoint 1, 0. Find y. So you have the coordinate A, which is -5, 5, and B, which is 7, y. The midpoint m between the two coordinates is 1, 0. Since the midpoint is the average of x and y values, so the average of -5 and 7 is 1. As you can see, -5 plus 7 divided by 2 equals 1. So the average of 5 and y should equal 0. So 5 plus y divided by 2 equals 0. So 5 plus y equals 0 and y equals -5. So the point B is 7, -5. Now, for example, you have 2 points A and B, where A is 1, 2 and point B is 4, 6. And you are asked to find out the distance between 2 points or the length of a line segment AB. So the distance between 2 points or the length of a line segment is given by x2 minus x1 whole square plus y2 minus y1 whole square, that is distance between x coordinate squared plus distance between y coordinates squared and square root of the whole thing. So let's call this x2 and y2 and 1 comma 2 as x1 and y1. So x2 minus x1 whole square is given by 4 minus 1 whole square, and y2 minus y1 whole square is given by 6 minus 2 whole square, and then square root. So 4 minus 1 is 3, so 3 square is 9, and 6 minus 2 is 4, so 4 square is 16, and square root. So 16 plus 9 is 25, and square root of 25 is 5. So the distance between point A and point B is 5 units. Now you need to find out the length of line segment PQ, or the distance between PQ. So the point P is negative 1 comma 3, and point Q is given by 5 comma negative 1. And the distance between 2 points is given by square root of distance between x coordinate square plus difference between y coordinates, y2 minus y1, again square. So let's call this x2 comma y2 and x1 comma y1. So square root of x2 minus x1. So 5 minus minus 1. 5 minus minus 1. That is 5 plus 1. Plus minus 1 minus 3. That is y2 minus y1. Whole square. 5 minus minus 1 is 5 plus 1, which is 6. So 6 square is 36. And negative 1, negative 3 is negative 4. And negative 4 square is 16. So 36 plus 16 equals 52. So the length of the line segment PQ is square root 52 units. So the length of line segment PQ is square root 52. So perpendicular bisector is a line that bisects another line segment at 90 degrees. So bisecting a line segment means dividing it into two equal parts. So here 2 points have coordinates A 5, 7 and B 9, negative 1. Now find the equation of perpendicular bisector of AB. So here you have A, that is 5, 7 and B 9, negative 1. And you need to find out the equation of this perpendicular bisector. Let's call this perpendicular bisector P. Since this perpendicular bisector is a straight line, it will have equation in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So first, you need to find out the gradient of perpendicular line P. But before this, we need to find out the gradient of line segment AB and use its gradient to find the gradient of line P. So let's call the gradient of line AB as MAB. Gradient is change in y over change in x. So this becomes y2 minus y1, that is difference in y coordinates, divided by x2 minus x1. Let's call this x1 comma y1 and x2 comma y2. So the gradient will become negative 1, negative 7 divided by 9 minus 5. So negative 1, negative 7 is negative 8 divided by 9 minus 5, which is 4. So 4 1 times and 4 2 times. So the gradient of line AB equals negative 2. So MAB equals negative 2. Now understand that perpendicular lines have gradient that are negative reciprocal of each other. For example, if you have a line which has gradient 3 over 4, then the line perpendicular to it will have gradient negative 4 over 3. Let's take another example. If you have a line that has a gradient of 3, then the line perpendicular to it will have gradient -1/3. So you can clearly see that perpendicular lines have gradient that are negative reciprocal of each other. So if the gradient of line segment AB is -2, then the gradient of line P would be 1/2. Now, in order to divide the line segment AB into two equal parts, perpendicular bisector needs to pass through the midpoint of AB. Let's call the coordinates of midpoint of AB as M. Now, to find the midpoint, we take the average of x and y values. So, M would be 5 plus 9 divided by 2, comma 7 plus -1 divided by 2. So the coordinates of midpoint would become 5 plus 9 is 14, 14 divided by 2 is 7, and 7 minus 1 is 6, 6 divided by 2 is 3. So the coordinates of M would be 7, 3. Now finally, the equation of perpendicular line would become y equals mx plus c, where m is the gradient, which is 1/2, and c is the y-intercept. Now to find the y-intercept of the perpendicular line, we will use the coordinates 7, 3, since the perpendicular line would pass through 7, 3. So for y, we will use 3. So 3 equals m, which is 1/2, x, which is 7, plus c. So 3 equals 7/2 plus c. So 3 minus 7/2 equals c. So c equals -1/2. Now finally, equation of perpendicular bisector will become y equals 1/2x minus 1/2. Now let's try some questions. The line has equation 3y equals 2 minus x. Find the gradient of the line. So you can rewrite the equation as 3y equals -x plus 2. And the equation of a straight line is in the form y equals mx plus c. So to convert this equation in the form y equals mx plus c, you will divide whole equation by 3. So the equation becomes y equals -1/3x plus 2/3. So -1/3 is the gradient and 2/3 is the y-intercept. So the gradient is -1/3. Now the line passes through the point 5, k. Find the value of k. So the equation is 3y equals 2 minus x. And for y, you will substitute k. So 3k equals 2 minus, and for x, you will substitute 5. So 3k equals 2 minus 5, which is -3. And k equals -3 divided by 3. So k equals -1. Now A is the point 0, 4 and B is the point -6, 1. M is the midpoint of AB. Find the coordinates of M. So you have A as 0, 4 and you have B as -6, 1. So the midpoint M is given by the average of x and y values. So M equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's call this x1, y1 and x2, y2. So midpoint M is given by -6 plus 0 divided by 2, 1 plus 4 divided by 2. So -6 plus 0 is -6 and -6 divided by 2 is -3, 1 plus 4, which is 5, divided by 2 is 5/2. 5/2 is same as 2.5. So the midpoint is negative 3 comma 5 over 2, or you can write negative 3 comma 2.5. Now find the equation of line AB. The equation of line is given by y equals mx plus c, where m is the gradient and c is the y-intercept. And m, which is gradient, is given by y2 minus y1, that is change in x, divided by x2 minus x1, that is change in y. So m equals y2 minus y1, which is 1 minus 4, divided by x2 minus x1, which is negative 6, negative 0. 1 minus 4 is negative 3, divided by negative 6. So this becomes 1 over 2. So y equals 1 over 2 x plus c. Now you know that the line passes through 0, 4. That means x coordinate is 0 and y coordinate is 4. So this point is 0, 4. So the y-intercept is clearly 4. Remember that y-intercept is the y value where the line intersects the y-axis. Or you can say y-intercept is the y value when x equals 0. So the equation becomes y equals 1 over 2 x plus 4. Find the coordinates of the point where the line 2y equals 3x plus 15 crosses the y-axis. So you have a line 2y equals 3x plus 15. Y-axis and x-axis. You have a line with positive gradient, and this line crosses the y-axis, for example, at point K. So we need to find out the coordinates of point K. Now remember that at y-axis, or x coordinate is 0. For example, this coordinate can be 0, 1, 0, 2, 0, 3, 0, 4. So at y-axis, all x coordinates are 0. So the coordinates of K will be in the form 0, y. Now 2y equals 3. For x, we will substitute 0 plus 15. So 2y equals 15. So y equals 15 divided by 2. So y equals 15 over 2, that is 7.5. So the coordinates of K are 0, 15 over 2, or you can rewrite it as 0, 7.5. Now observe that this line is passing through 0, 7.5. That means when x equals 0, y value is 7.5. So I can say the y-intercept of this line is 7.5 or 15 over 2. That means if I rearrange this equation in the form y equals mx plus c, I need to get y-intercept as 7.5. So 2y equals 3x plus 15. And to convert this in the form y equals mx plus c, we will divide equation by 2. So y equals 3 over 2 x plus 15 over 2. Since y equals mx plus c, so m equals 3 over 2 and c equals 15 over 2. So instead of substituting x equals 0 and then finding out the value of y, we could have just rearranged the equation in the form y equals mx plus c, which would eventually give us the y-intercept and the coordinates of k. The coordinates of k are 0, 15 over 2. So if any question asks you to find the coordinates where the line crosses the y-axis, that means they are asking about 0, y. And this y needs to be the y-intercept. You can calculate this y-intercept by substituting x equals 0 into the original equation, or by simply rearranging the equation in the form y equals mx plus c. And this y value is the y-intercept c. Now A is the point 0, 3, and B is the point 1, 5, and C is the point P, negative 1. Find the equation of the line AB. So you have A, that is 0, 3, and B, that is 1, 5. Now the equation will be in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So m equals y2 minus y1 divided by x2 minus x1. Let's call this x1 y1 and x2 y2. So m equals 5 minus 3 divided by 1 minus 0. So m equals 5 minus 3 is 2 and 1 minus 0 is 1. So m equals 2 over 1, or simply 2. Now for the y-intercept, observe that the line is passing through 0, 3. That means the x value is 0 and y value is 3. So the y-intercept needs to be 3. Since y-intercept is the y value at which the line intersects the y-axis, or y-intercept is the y value when x equals 0. So the equation becomes y equals 2x plus 3. Now the gradient of BC equals negative 3 over 4. So gradient is again y2 minus y1 divided by x2 minus x1. So let's call this x1 y1 and x2 y2. So the gradient is minus 1 minus 5 divided by p minus 1. So minus 1 minus 5 is minus 6 divided by p minus 1, and the gradient is negative 3 over 4. So p minus 1 multiplied by negative 3 equals 4 times negative 6. That is negative 24. So negative 3p plus 3 equals negative 24. So negative 3p equals negative 24, negative 3, that is negative 27. So negative 3p equals negative 27, and p equals negative 27 divided by negative 3. So p equals 9. P equals 9. Here are the equations of 4 straight lines, line 1, 2, 3, and 4. Which two lines are parallel? That means which two lines have the same gradient? Equation of line is in the form y equals mx plus c, where m is the gradient. So I can see that line 1 has the gradient of 2, and line 3 also has the gradient of 2. So line 1 and line 3 are parallel. Now which two lines intersect y-axis at the same point? So at y-axis, the x-coordinate is 0, and the y-coordinate gives us the y-intercept. So simply they are asking which two lines have the same y-intercept, or which two lines intersect y-axis at the same point. So first, I'll rearrange line 4 in the form y equals mx plus c. So line 4 is 2y minus 8 equals 3x. So 2y equals 3x plus 8. Now divide by 2, divided by 2, divided by 2. So y equals 3 over 2x plus 4. So line 4 has y-intercept of 4, and line 1 also has y-intercept of 4. So line 1 and line 4 has the same y-intercept, or you can say they both will pass through 0, 4. The 3 points A1, 3, B13, 11, and C6, 15 are shown in the diagram. The perpendicular from C to AB meets AB at point D. Find the equation of CD. Now the equation of line CD should be in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So first, we will find out the gradient of line CD. So we need to find MCD. But before the gradient of CD, we need to find out the gradient of line AB. So NAB is y2 minus y1 divided by x2 minus x1. So let's call this x2 comma y2 and x1 comma y1. So y2 minus y1 is 11 minus 3 and x2 minus x1 is 13 minus 1. So 11 minus 3 is 8 and 13 minus 1 is 12. Now 4 2 times 8 and 4 3 times 12. So the gradient of line AB is 2 over 3. Now the gradient of line CD, which is perpendicular to line AB, should be the negative reciprocal of 2 over 3. So the gradient of line CD equals negative 3 over 2. Now we need to find out the value of y-intercept. So to find the y-intercept of CD, we need to substitute 6, 15 for x and y. So equation of line CD is y equals mx plus c, and where m is negative 3 over 2. So y equals negative 3 over 2x plus c. Now for y, I'll substitute 15. And for x, I'll substitute 6. Negative 3 over 2, 6 plus c. 2 1 times and 2 3 times. So 15 equals negative 3 times 3, negative 9 plus c. So 15 plus 9 equals c, and c equals 24. So the equation of line CD becomes y equals negative 3 over 2x plus 24. So the equation of CD is y equals negative 3 over 2x plus 24. Now we need to find out the coordinates of D. So you can observe that you have a line segment AB and you have another line segment CD. And the point of intersection of both lines is D. So we have learned that if you need to find out the point of intersection of two line segments, you solve their equations simultaneously. So first, we need to find out the equation of line AB. The equation of line AB should be in the form y equals mx plus c, where m is 2 over 3, y equals 2 over 3x plus c. Now to find the value of c, we can either substitute 1, 3 or 13, 11. So I am substituting 1, 3. So 3 equals 2 over 3 and for x1 plus c. 3 minus 2 over 3 equals c, and c equals 7 over 3. So the equation of line AB becomes y equals 2 over 3x plus 7 over 3. Now you have CD equals y equals negative 3 over 2x plus 24, and you have AB as y equals 2 over 3x plus 7 over 3. So you need to solve both equations simultaneously to find out the point of intersection D. So let's call this equation 1 and equation 2. Now select any of the two equations. So I'm selecting equation 1. The equation 1 is y equals negative 3 over 2x plus 24. Now for this value of y, I can use 2 over 3x plus 7 over 3. Since y also equals 2 over 3x plus 7 over 3. So 2 over 3x plus 7 over 3, which is y, equals negative 3 over 2x plus 24. So this is y equals y. Now rearrange the equation. 2 over 3x plus 3 over 2x equals 24 minus 7 over 3. So 13 over 6x equals 65 over 3. So 13x equals 65 times 6 divided by 3. 3 1 and 3 2. So 13x equals 130 and x equals 10. Now you have the value of x, and you can either use equation 1 or equation 2 to find the value of y. So I'm using equation 1. So y equals negative 3 over 2x plus 24. And for x, you will substitute 10. So 2 1 times and 2 5 times 10. So y equals negative 3 5 times 15 plus 24. So y equals 9. So the coordinates of D are 10, 9.